Welcome, David. Good to have you with us.
Hey, nice to be back, David. Thanks for having me.
Oh, sure thing. Always a pleasure. So let me just quickly introduce what we want to talk about. Going back to the 40s and perhaps even a bit earlier, printed circuit boards have been this foundational element in just about all electronic systems.
Yep.
When it comes to today's high frequency RF and microwave circuits, PCBs can really determine how well your system's going to perform. It can really limit you, or it can just set everything free to fly. You've got signal reflection losses that come from impedance mismatches. You've got losses from the dielectrics and
Mhm.
dissipation factors, and all of these things have been of concern to designers for a long time. But when you get to these higher frequencies, microwave frequencies, 100 gigahertz, what have you, the PCB can really make or break you.
Mhm.
So today we'll discuss some of those issues and trends that our friends at Cadence are seeing in RF PCB design. So to start off, David, can you just talk a little about some of the trends that you're seeing in the marketplace in PCB system architectures? I know there's things like multi-board 3D systems, there's high density
Yeah.
interconnects.
Yeah.
What's catching your eye these days?
Yeah. Well, thanks, David. That's a lot. And you jumped immediately to millimeter wave, and my head was thinking more in terms of the maybe 5G driven, IoT driven, just the
Mhm.
ubiquity of wireless technology as we've watched it evolve over the last 20 years. And so a lot of what I think the technology is doing and these applications are doing is driving large scale adoption of RF and wireless technology implemented at the PCB. But we've also seen kind of this convergence between more than more and the evolution of chiplets and heterogeneous integration that's taking
Mhm.
place within the module, which is kind of a specialized form of the PCB.
Yep.
The trend's always been, let's say increased complexity and a drive towards miniaturization. The complexity is necessary to pack more functionality into a smaller space. And that's what, these our wireless systems are demanding. It's what customers are demanding out of our cell phones and every other wireless device that's being adopted. So to your question, you mentioned, before, we jump into, supporting millimeter wave and 100 gigahertz design, things such as like a multi-board 3D system, certainly addresses the ever increasing need for complexity and
Mhm.
miniaturization. I think it kind of mirrors what's happening at the chiplet heterogeneous integration level,
Mhm.
in that we try to reuse design where possible, and design into boards and then combine boards. And so that's why I think there's an uptick in the use of multi-board systems.
Mhm.
You can have dedicated functionality into regions of boards or dedicated single boards. And then a big part of the engineering focus then has to shift focus to the interconnect between multi-board systems.
Mhm.
That's the area where you're probably most vulnerable with regards to, as you mentioned at the top, reflections and losses and whatnot. So there's a lot of attention being spent on the highest quality possible connectors to preserve signal integrity across, between boards,
Yep.
and also how these boards are being assembled and stacked. We see odd-shaped connectors, a lot of custom connectors for interboard connectivity in mobile devices and laptop motherboards. And in general, these multi-board connections, either they're short cables or they're a direct connection. In either case, there's a lot of 3D modeling that's
Mhm.
required. So we're seeing a convergence of, ECAD, which is kind of my world, electrical design,
Mhm.
needing to partner well and play well with MCAD, mechanical design.
Mhm.
As we're stacking, we've got to be concerned with the heights of components on the board. You don't want to get to a situation where you're mid-manufacturing and you've discovered that's a problem that you hadn't accounted for. So we're really seeing a convergence of a need to partner between the electrical design team and those tools and the mechanical team as well. And of course, all of this is driving to reduce the size. So, that's where we're really trying to shave some space and pack more functionality in. MCAD, mechanical and electrical design tools are really kind of, needing to have a way to talk to each other. And we've been doing that on the Cadence side, largely with, we've got the ECAD side covered pretty well. A few years ago, we struck up a partnership with Dassault. That's their flagship product is SolidWorks, and they've got a strong foothold in the mechanical space. And so we find it's a very powerful partnership that we're working together to address these 3D board PCB systems.